Today's notes cover 7.3, the rhombus and square. So a rhombus is a parallelogram with 4 equal sides. The properties of a rhombus include 4 equal sides. The diagonals bisect the angles. The diagonals are perpendicular bisectors of each other. And they include all the properties of a parallelogram. Okay, so let's take a look at a rhombus. Example 1 is a rhombus. So we know that the sides are all congruent. We know that the diagonals are going to bisect the angles. So each of these angles has been bisected. That means it's been cut in half. So you have 2 little congruent pieces right next to each other. This larger angle has been bisected. That means it's been cut in half. So this piece is congruent to this piece. And it works that way with all the angles. So I'm going to do 3 little marks down here and then 4 little marks. All right? Let's see what else. We know that diagonals are perpendicular. So right here where the diagonals intersect, they're perpendicular and they bisect. So I know that these are going to have right angles, and then we're going to be bisecting. So each of these segments is cut in half. So I'm going to draw some congruency marks so I know what's equal to what. And then they have all the properties of parallelograms. And so we know that with a parallelogram that opposite angles are congruent. And so you know what I can do is, let me go ahead and clean this up a little bit. Since I know my opposite angles are congruent, these angles are going to be congruent to these. And let me go ahead and clean this up a little bit. These angles are going to be congruent to these. Opposite angles are congruent. And then these angles, adjacent angles, are going to be supplementary. So we have a lot of information on this rhombus. Okay, so now let's see what we've been given. We know that the measure of HRB is 40. So HRB, that is this angle here, H to R to B. So that's going to be this angle right here, and that's 40. Well, that means this guy is also 40, and this guy is 40, and this guy is 40. Okay? And so this angle here, this larger angle, is 80. And so I know that this angle down here is going to be 100 because adjacent angles are supplementary. And so if this is going to be 100 down here, I've got to bisect it. So each of these little guys is 50. Okay, and so then these guys are also 50. And now I think I can probably answer all these questions. Well, let me think. Now, let me look at one more thing. I'm going to highlight now this top triangle. If I know that these 2 angles in this little red triangle add up to 90, and this guy is 90, yeah, I know all these angles now. All right, let's answer the question. So it says, what is the measure, I'm looking at this guy here, measure of angle BMO, so B to M to O. That is this angle right here, from B to M to O, so that's 50 degrees. Now, what is the measure of angle OBH? So O to B to H, that's a right angle, okay? We have a straight line, that's 90. We know that the diagonals are perpendicular, so that one's 90. And then the last one, MRO, so from M to R to O, that is this angle here at the top, and that's 40. All right, let's take a look at another rhombus. Okay, this time we're looking at the side lengths. So let's put some marks on it. Diagonals bisect each other. and are congruent. And so if this segment here is 9, then I know that this segment here is also 9. Opposite sides are congruent, and so I know that those are both 15. And let's see what the question's asking us. What is the measure of RH? RH, of course, it's asking us for this side here. Well, let's see. We know that the by these guys, the diagonals are perpendicular. So I know that I've got right angles. And if I have a right angle, well, and I know that these are, let's see, oh, and a rhombus has all sides are congruent. These are all 15. I can use Pythagorean theorem. Okay, here is my right triangle. Okay, so if I know that the leg on this triangle is 9, the hypotenuse across the box is 15, I can set my x right here and then solve. And so let's call this guy x. And I'm trying to figure out, I'm trying to figure out what RH, that's just 15. But now BH, now I got to do that. Okay, so let's use Pythagorean theorem. And so 9 squared plus x squared is equal to 15 squared. Okay, you with me? We have a right triangle. Here's the right angle. That means this guy 15 is the hypotenuse. And Pythagorean theorem says that a squared plus b squared is equal to c squared is equal to the hypotenuse squared. Let's go ahead and work this out. X squared is equal to 15 squared minus 9 squared. I'm going to take that to Desmos. Whoops. 15 squared minus 9 squared. I know the square root of 144 is 12. So x is equal to 12. All right, we got one more rhombus before we move on to the square. Okay, so measure of MRH is 3x plus 14. So this big angle here is 3x plus 14. The measure of MOH is 98. Hey, well, we know that opposite angles are congruent, so I can set those equal and solve. If I subtract 14 on both sides, what is that going to be? 84. And if I divide both sides by 3, x is equal to how about 28? All right, now we need to find the measure of RBH. Oh, well, diagonals are perpendicular, so that's an easy. That's a 90. Okay, one more before we move on to the square. The perimeter is 80. Okay, so earlier we talked about the 4 equal sides. If the perimeter is 80, I just need to divide this by 4. So each of these guys is 20. I don't know if I need that, but let's see. Yep, BC is 20. DC is 20 also. That was easy. All right, now let's talk about a square. Properties of a square. Well, a square is a parallelogram with 4 equal sides and 4 right angles. A square has all the properties of a rectangle, a rhombus, and a parallelogram. Let's take a look at a square. Okay, so in example 4, we know that the square has 4 congruent sides. Let's set these equal to each other and solve for x. Subtract x, add 9. So 4x is equal to 10, and if I divide, x is going to equal to 2.5. 10 divided by 4 is 10 over 4, which is 5 over 2, which is 2.5. I can plug it in right here, so 2.5 plus 1 is 3.5, and I just need to multiply that by 4 to get the total perimeter. So I know 3 times 4 is 12, and 4 times a half is 2, so 12 and 2 is 14. The perimeter of this square is 14. All right, let's take a look at example 5. Okay, so in example 5, the diagonals are congruent and they are perpendicular bisectors and they are angle bisectors. And in a square, each of those angles is 90. And so if I want to know what CB is, well, these are each 6, so that's going to be 12. If I want to know what BD is, okay, so now we're looking at a triangle, a right triangle, and so we can use our Pythagorean theorem. Let's see. Each of these sides is congruent. So this is going to be x squared plus x squared is equal to 12 squared. Pythagorean theorem. We don't know these sides, but we know they're congruent. So let's just call those my x. And the sum of these two, 6 and 6, make the 12, and that's what I've got here. All right, so this gives me 2x squared, because if you have one x squared and another, that makes 2. And this is equal to 144. Divide both sides by 2, so x squared is equal to, what is that, 72. And if I take the square root of 72, let's just get a decimal approximate. So let's see if I can clear up some of my Desmos calculations. Square root of 72 is about 8.5. So x is approximately 8.5. Measure of angle ABD, A to B to D, well, this is a right angle, so that's 90 degrees. And the measure of ACB, okay, so we know that the angles are bisected. Half of 90 is 45. And I think that's it.